Hi, hello, my name is Marek and I'm DBT Tech Lead at Travel BI. I'm really happy you could join us today and we have prepared 4 topics that we think you will find really interesting. Whether you are working with DBT every day or just starting to explore it. The whole session should take around 1 hour. And before we dive in, let me tell you a bit about the Revel BI. We are a data company that helps business get more value from their data, from collecting and modeling it, all the ways to visualization and automation. We focus on the modern data stack using tools like dbt, Snowflake, and AI to build efficient data, process, and high quality analytics. We are also an official dbt Labs partner. We are already helping companies implement dbt in their data workflows and supporting teams who are transitioning from dbt core to dbt cloud and fusion. Just last week, the Coalesced conference took place in Las Vegas, where dbt Labs announcement dbt fusion in preview. It brought some really exciting updates to the dbt world, and we are super excited about them too. And all 4 topics show how dbt and the data ecosystem keep evolving. So here what we will cover today. First, Anton will show how Fusion makes life easier for developers with syntax checks, autocomplete, dependency tracking, and many other features that improve the development experience. Katya will demonstrate how Fusion can intelligently manage models, runs, and skip those that haven't changed, save both time and money. Kirill will talk about using CI pipeline in dbt Cloud to improve code quality, speed up reviews, and make deployments safer. And finally, Luboš will introduce the MCP server, which connect dbt with the semantic layer and unlock new ways to use data in AI and BI tools. All of these topics highlight how dbt continues to evolve and what's possible today if you want to build modern, smart data stack. Please feel free to post your question in the chat. We will answer some of them at the end.
That change how dbt analyzes and processes metadata and how it works with that data much more efficient. Before we start talking about base code extension, I want to talk with you about Fusion. Fusion is the new core of dbt. It makes code compilation, SQL analysis, and dependency handling much faster and smarter. It enables what we call local SQL analysis, which means that dbt can understand relationships between models and columns before running them. So now dbt can recognize where each column comes from, understand model dependencies, detect errors earlier, compile code much faster, can make smart orchestration, and much more. So with Fusion and the base code extension, we now get real-time SQL analysis. Errors appear instantly before the model even runs. It's not just syntax checking. dbt actually parses your code and understands the context. So we can now see missing commas or bad keywords, automatic reference with dependencies and errors in them, and database results. This means we catch issues early, right while writing our SQL. So we don't need more waiting for a failed build or a CI choke to see what went wrong. All these improvements together mean faster development, safer and more reliable pipelines, real-time visibility into dependencies, and for sure, that saved a lot of money. Teams which already test in Fusion right now report that build times dropped from tens of minutes to just a few, and issues are detected much earlier than before the CI choke. This is a big productivity boost of data teams. So when and where we can use our Fusion? I want to tell you that we can use it everywhere and always. So Fusion really helps where teams struggle with SQL mistakes, dependencies between models, and they save and they have too much time of debugging. And now with the dbt VS Code extension powered by Fusion, we can actually see all this in action directly in our editor. So let's go through a few short demos to show what it can do. Give me some second. Okay. Before we start into demos, I want to show you where we can find that extension. So we just need to click the extensions, write dbt, and install it. Here you can find all the information that this extension can do, but I want to tell you this more like I want to tell you like the cool things about that extension. So the first thing, imagine you writing a new model and you can't remember the exact name or model or a column. Thanks to that dbt extension, Fusion offers real-time autocomplete for model names, columns, macros, and SQL functions. So for example, I just want to write the reference. Just need to write ref, put it here, and now we can find all the models that we are using in our project. So for example, I forgot the order's name. My mistake. I just click on it, save, and that's all. So one more thing here, no more blind SQL. For example, you can always see exactly what you are using, including data types. So one thing that you need, you just put your mouse here on the star, and you see all the columns that we are using in our orders model and data types for that. Let's go to the second demo. Let me show you. For example, we have tons of model, and we want to know, for example, find where user ID is used. With just one click, you can jump directly to its definition, even if it's in another model. So you can need to right-click, go to definition, and you can jump exactly to the model where this user ID is. So exactly from the orders, we can go to the stage model, for example. Or imagine, for example, we need to rename our column. You got a ticket that you need to rename the user ID, for example, to the user ID new. We need to save it. Now you'll see that the model is highlighted in red. So dbt detects the issue before anything runs in the database, which saves both like time and money. Right now, we just need to put our mouse here, and it says, okay, so no column user ID found, available are, and it shows all the columns that we are using in our model orders. So I know that we change it to user ID new. So I just put it here. Yes, and that's green, so that's great. I just want to return it back, okay? I don't know, the seed. So let's go to the third demo. Imagine one more time you have 1,000 models in your project, and you need to quickly find the dependencies between your models. And in the lineage tab here, when you click it, you can navigate through the project, open related models, and see dependencies down to the column level, all without like leaving our editor. So we don't need to go to our database, Snowflake, BigQuery, Databricks, for example. We just can do it all here. So one thing that we need to do, we just go to demo 3.1. And for example, we need to change something in our payments table. So we just need to double click on it and jump to here. Or we want to show all our project. We just need to jump here and we see all models that we are using in our project and their dependencies. But most cool thing here, that's the column dependencies. So for example, we've got some ticket, for example, that we need to know something about amount average column. So we just need to right click here, show column lineage, and choose the amount average here. So, and now you can see how that column goes from all the project. So some raw data, then we've got a ticket to rename our amount to amount new. Then business said that we need to make some transformations here on amount average, and that's the DM. So also here that I want to show you, I know you're like nightmare of every developer. So I know that you have some mistakes, even you are like sitting with your work at night and for example, you forgot to put the comma here. And exactly that's the time. In that time, dbt shows you that you have something here, no viable alternative. And I'm said, okay, maybe I've forgotten something. So we just need to put the comma here, save it, and that's clean again. Or for example, I forgot some aggregated column, which we need to use in group by. Again, we have some problem here. We just need to put our mouse here. And we see unaggregated columns in aggregation context. Audit ID must be aggregated or appear in a group by clause. So one thing that we need just to add the audit ID, or we even like forgot some group by, for example. Exactly the same context here. So unaggregated columns, blah, 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 must be aggregated or appear in a group. Okay. One thing here in that demo, I know that we can't remember all the functions that we are using in our SQL or when we are writing, so we need to go to some Snowflake documentation, Databricks documentation, for example. But now, when you remember maybe like just a part of the of your function, for example, datediff, we just need to write the datediff here. And the extension will automatically show you how many and which arguments should be used here. So you can't remember with the dbt fusion on parameters that you need to use in your function. So that's the very cool thing. And then finally, go to the demo 4. Let's look at syntax checking based on your adapter. So the adapter meaning like which database is connected, such as Snowflake, Databricks, BigQuery, Redshift, wherever you are using. So when you switch from Snowflake to Databricks, for example, you need to, I don't know, like you've got the ticket that you need to merge your code from the Snowflake to Databricks. Just need to rename the type of our adapter here to Databricks. And here also. Save it. And right now, we will see the problem here. Yeah, here, excuse me. So it said that Databricks doesn't have the try to date function. And it says no function try to date. So one thing that we know that Databricks using only the like to date. So we just need to rename it. For example, like here, but I want to return it back, okay? So here I want to show you something with these buttons. That's the last one. And the most popular dbt feature is the compile code. So every one of you who are using the dbt knows the like dbt compile function here in terminal, but now it's like really easy to do. You just need to click on compile file here, and you'll see your compiled code here. So you can view the compiled SQL right next to your model, and it's online. So for example, you have some unresolved column here, and you will see it when I'm saving it right now. So very cool feature. It's not only working with some like references, it's also working with some sources with your macros. When you, for example, have macro on I don't know, like maybe 19 rows, and in your code you have only one. So that's the really cool feature. Then you can find maybe some problem with your macro, and maybe, for example, you forgot from where you've got this or this model. And the very last thing here, that's the query result. So when you click on the preview file here, you see how our query looks like here in a table. That's the really helpful feature. For example, when you have some problem or we have some unknowns, we have, I don't know, like whatever you want, you just right click here, preview your file, find something problem, and you don't need to go to your databases. So that's really cool. But the most cool things here with these query results is the preview CD. I'm just having only one, but when you have, for example, 10 of them or 20 of them, I don't know like how big your tables are, you can just click on the preview CD and you will see the query results only from that CD. So you just don't need to copy that from, I don't know, like from the compile code here, go to database, insert it, run it. So that saves a lot of time, a lot of money. And I think that dbt Fusion is like perfect thing for debugging your code, for save your time. So I think that's all from my side. And I'm giving the floor to my colleague, Katya. Thank you so much, guys.
Right, hello everyone. I hope you can see my screen and hear me clearly. So good afternoon, my name is Kateřina Protivenskyi, and today I will tell you a little bit about state-aware orchestration. I will tell you what it is, how it works. I will also show you a demo, and then we will discuss how you can customize it, fine-tune it a little bit to match your needs a little bit more. And then we will also discuss what this new feature can actually bring you and how you can benefit from it. But before we start, let's recap how we work today. What is the situation we are currently in? Basically, always when we run our jobs, the pipeline runs all the tables that are involved in this job. Every single table, every single model is recalculated and rebuilt. Even if there is no change, there is no new data, the tables are rebuilt anyway. So we basically waste a little bit of time and money. So how it would be great if we have a tool or a way that we can rerun only models and tables that are actually changed and there are some data change involved. This is exactly what state-aware orchestration can solve and do for us. So state-aware orchestration is an innovation that is powered by Fusion, new engine that was described by Anton before. And basically what is happening behind is that dbt right now compares the current state of dbt with the previous one, identifies changes, and run only those models that are affected by these changes and nothing else. Everything that is not affected by any change will be simply reused as is. And how dbt knows what to do, how dbt knows what to run, it is actually checking the metadata that are already saved and stored in your warehouse. And I will show you where and how. Let's have a look also at a simple example so we are all on the same page and we understand exactly how it works. We can see very simple DBT DAG that has 4 sources on the left side. All these greens are sources. And then there are 9 models that are basically taking the data from these 4 sources. Let's say only 1 source out of 4 gets new data. What would happen in any traditional orchestration tool would be that all the 9 models that are following would be rerun. But what the state-aware orchestration will do is that only these 3 models will run and the rest will stay still unchanged. So basically we are running only 3 models out of 9 and 6 of them will stay unchanged. To use this feature and benefit from this feature, you need to also fulfill some requirements and fulfill some prerequisites. First of all, you need to have a DBT Enterprise account. Then you need to migrate to Fusion and also have production environment setup. Unfortunately, currently, generic environments and development environments don't have this feature available. And also only SQL models are supported by this feature in a current moment. So no Python models work with this feature right now. So what is actually the main goal of state-aware orchestration? So of course, I believe you already could guess. So the main goal is to save money, right? Because we run only what got changed, not the rest. And also the other goal is to reduce complexity. What I mean by complexity is, for example, imagine you have multiple jobs and they run on different frequency, on different schedule. So with this functionality, we will make sure that one job is not gonna override the models of the different job, right? So there will be no conflict. We will not be building the models if it's not really necessary, even if they are part of multiple jobs. So this is what I mean by reducing complexity. So right now it's demo time. Let's have a look how it works in reality. So we have prepared 2 things. First is a DBT job that we are gonna run, and then we have our warehouse in Snowflake. As I already mentioned, DBT runs only what got changed, and it reads the metadata from your warehouse. So let's have a look what we have here. We have here some sources, and we can also see when they got changed. So they were changed a couple of days ago. The last one was yesterday for this orders training. It got updated 22nd October 2025, which was yesterday. We are going to simulate a situation that one of these sources got updated and received new data. We are going to only simulate it by inserting new row by the insert statement. So let me just check the row got inserted correctly. We have it here. And let me check the metadata one more time. And we can see the timestamp when orders training was updated, changed from 22nd to 23rd. So it got updated. And right now we can run our model. And I will show you how you can identify that your job was running with state-aware. It will take a little bit of time, just a couple of seconds. This is gonna be a moment of truth. Okay. And what we can see here is success-free, reused 6. So if you remember the DAG from the previous slides, we had 9 models and we changed 1 source, right? And on that 1 source, there were 3 models dependent: orders and sales and stage orders. And these were rerun because the source got changed. And when we also click on the logs, we can exactly see what is happening inside. And we can see that DBT tells us you have new changes detected. So that is the reason why these 3 models run again and they were rebuilt. So this is what the success means. The rest, the 6 models, they were only reused. And again, you can easily see it in the logs. No new changes detected on any upstreams. So they were simply reused as they are. And you can also clearly see it from the lineage. Maybe it would be a little bit more easy to understand from the picture because the source of stage orders got changed. Only these 3 following models run and they will rebuild again, and the rest stayed unchanged. So let me get back to the presentation. If you would not like the behavior as it is right now, or you would like to a little bit customize it, fine tune it to match your needs a little bit more, you certainly can. There are several parameters that you can use to fine tune it. So there are 4. So first of them is loaded at field. So again, I will just remind that the DBT currently is using metadata, right? As I showed you just before. But if you don't want it, you don't want to use metadata from your warehouse. And for example, in your source data, you have a timestamp that tells you if your data is fresh or not, something like updated on, created on, something like that. You can use this field instead, which is very powerful on your sources level. If you don't have such a column, or you don't want to use a column and you have a SQL logic that defines if your data is fresh or not, you can use a complete SQL logic that you can put into the other parameter loaded at query. You can use only one of them, not both of them in the same time. So either column or a full SQL query that would define what it means fresh data. Another 2 parameters that we have is built after and updates on, and we will spend there a little bit more time, and I will show you also the example how to use these 2. So first example is related to the parameter built after. Again, we can see here the DAG that we are already familiar with these 9 models. And in DBT, every model, every table actually has a YAML file where you can configure that model. For example, you can put there tests, whatever it can be. And also this is the place where this parameter would be placed. So here what I did, at the end of our DAG on a sales model, I put the parameter built after and I set it to 24 hours. It can be set in hours, minutes, days, whatever you can imagine. And basically what it will do with this setting is, even if we have new data in orders, and it would come, for example, every hour we will get new data in these 2 models. But this one is set, refresh it only once per 24 hours. So it would ignore that here we have new data and it would be rebuilt only once per day. You can also see it easily in the logs that it says we defined, like we see the changes, but we have this condition built after 1 day and you don't meet it because basically, I rebuilt this model for this demo 26 minutes ago. So it's one thing you can do with this configuration. And another example is updates on, and I set it for this example to all. And again, you can see that sales model was not rebuilt, even if we have new data on the upstreams models. What it means, this setting says that the sales model would be rebuilt only if all upstreams would have new data. And in this condition, we can see only one upstream had new data, not all of them. So that's the reason why the sales model was not rebuilt again. By default, this updates on is set to any. And if we would set it to any, then only one source, if it has new data, then sales would run. But with this setting that we have here on the screen, it will not, because it expects new data in all upstreams, not only one. So we covered all the technical part of state-aware orchestration, and you can see I didn't need to do a lot, right? It is a default behavior of DBT that has immediate impact on savings. I would like to also talk a little bit about the conference that happened last week in Vegas, where very interesting numbers were shared. And basically what DBT shared is that when you turn on state-aware orchestration, it can result in around 10% of savings. If you then rethink how you orchestrate your data, and you will start using the parameters and set it exactly as you need, it can result into additional 15%. And then there are 4 additional % of savings with effective testing. What it means, effective testing, is that basically if you run only models that got changed, also tests on these models will run only. On the reused models, the tests will not run because it doesn't make any sense, because they were not rebuilt, right? So this is additional 4%, so it can be in total around 29% of savings. Of course, every situation is different, right? Every customer, every situation is very unique, but there is one rule that's valid, and basically more complicated situation you are in, more jobs you have, more schedules. For example, one job is running on daily, another on weekly or hourly. So more complex this situation is, more you can benefit with state-aware orchestration. Let's also have a look at the real example and real case, how much money DBT Labs saved with this new feature. Basically, when they started, they had around 1,500 models, and they had around 30 jobs, which is quite a lot, and it had different schedules. So some were running on daily schedule, hourly schedule, and so on. When they turned on state-aware orchestration, 35 their models were already reused, and it resulted in 9% of savings. Then they completely readjusted how they orchestrate the data, and they were able to reduce 30 jobs into only 2, which resulted into 55 additional % of savings, and they ended up with 64% of savings, which is quite incredible number. And when we speak about money, it was previously they spent $850,000, and they were able to reduce this to only $259,000. So to conclude this presentation, I would like to just remind that this feature can be reused only if you have the enterprise account. And also, if you already have a DBT Cloud, all the jobs that are running there and you will migrate to Fusion, they would be set as they are. They will not be state-aware by default. You would need to change it. But all newly created jobs would be state-aware by default. And if you don't like this feature for any reason, or you don't want to use it for any reason, it is also possible to turn it off in the settings of the job itself. So this is it from my side. Also, you can see here some resources. So if this presentation would be shared with you, then you can read a little bit more about that. So thank you for your attention, and I will give a word to my colleague, Kirill.
Hello, everybody. I hope you hear me well. My name is Kirill, and I'm working at Revel BI as a data engineer. And I'll talk today about next interesting topic, CI pipeline. CI pipeline or CI jobs. Okay, let's go. I believe the many of you guys facing with problems during release time, during emerging changes to higher environments. Let's take a look on a picture I have here. Let's imagine we have the dog like this, and let's imagine that we need to make change in this green model, in this green box. We made a change, we made a manual validation, looks like locally works, dbt run is green, but we're still not 100% sure how it will behave in high environment or in production. And how it works years before or even now, some teams work in this way that just pushing a code into production, cross fingers out, and hope that code will work. But it's not cool. And what is the solution that dbt Cloud has? It's CI job or continuous integration job. So how it works? When someone from your team, your colleague, some developer writes a new pull request with changes, the CI job will automatically run. It will build and test your changes in a temporary staging schema. So we don't need manual checks. We have a fully automated check, which will run even before we merged our code to higher environment. CI job, you can see this command here. So this command is running on a background, on a backend of every CI job. And CI job using the state modified selector. And state modified selector working the way that it will compare the code from your PR with the code in the manifest JSON from the last successful run. And if it see any change, it will take this change and will build it. Also, you see we have this plus on the end of our state modified selector because we can make change in this green model and we are sure that it works. But what if this change can impact the downstream models? So state modified with plus on the end tells dbt run our change model and all downstream dependencies. So a CI job will not run the whole our project, only what is inside this red box. So we got the faster feedback if something is not good. And also we are saving our time because imagine we have such a big DAG that can run, for example, 2 hours. So we can't wait 2 hours to understand that we have problem in some model. And also we can optimize our compute costs because we're running only changed models, not the whole project. Okay, so you can think about CI job as a fully automatic check that run before you merge your code to high environment or to production, and you can really understand how your change will behave in higher environment. Okay, let's go to the demo part. I have here my project. Let's take a look on the orchestration section. Here we have the jobs. And if you will click on the create job, you have 3 types of jobs: deploy job, continuous integration job, and merge job. Today we are talking about continuous integration. You can click on it here, and I already have one. Let's take a look what parameters it has. Of course, the name of the job. I have a dev CI job. You can also have TST, test, UIT, production. What's the name in your company? Description for our colleagues so they can understand what the job do. Environment, I have dev. As I said, here you can have test, UIT, or production. CI job, as I was mentioned, is triggered by default on a new raised pull request. Here you can see the dbt build command with state modified selector, which will run only our changed models and their dependencies. And also here is a deferral, so we will run it defer to our dev environment. So that's all important parameters. Let's take a look on a studio. Studio, it's a development environment native in DBT Cloud. So you can see here your DBT project and run your models, edit your models, build it, compile your code, preview data. So you can think about it like Visual Studio, but dedicated for DBT development. You can see here my default branch, here the button like create branch, and let's imagine that we have the new requirement from business to change the order date here from date type to string. Okay, I will create a new branch. Change. Okay. Yeah. Submit. So now you can see that branch has changed to my feature branch here. And let's try to make the change. Here. Yeah, we can save it. And we can commit our change. Order date. CI. Commit changes. And let's try to create a pull request. We see our change here. Create pull request, create pull request. And let's take a look what our CI job will do. Now we see that we have open pull request here, and our CI job is already running. Also, you can see it here in GitHub, the DBT Cloud waiting for status, and also we can pro-click it here on details. So we'll get to our DBT Cloud project. So now it's failed. Okay, let's take a look why it's failed. Here, this model, we made a change. We made the date to the string, and it looks good. It's green, but the downstream model looks bad. And what we see here, someone had enforced contract in this model. Okay. But it's cool that we know that we have problem before we merge our code to higher environment or to production. Let's take a look and try to fix it. Let's go back to Studio. Let's go back and take a look why it's failed. Because in SQL, it looks like it should take order date as it is, so it should be string. But let's take a look in the YAML file. And yeah, here we see the contract enforced. So this model waits that order date will be only date, no string. So we need to make change here. So our order date will be string. Let's save it. And let's commit the change. Order date, fix, last. Commit changes. And new commit, new CI job run. Let's take a look. Let's take a look. Yes, it's running. Cross fingers. Let's load it. Oh, I forgot about it. Let's reload it one more time. And yes, it's green. Great. Great job. The model we change here is green. Next one now is also green. Let's take a look to our connected warehouse. We have Snowflake here. As I said, that it should be deployed, built in isolated schema staging. So here you can see the dbt cloud, the number of PR, and here you can see our tables, stage order CI and order CI. So we are good. And now we can go to our GitHub. Here you can also see that all checks have passed. You have this check green. So we are safe with merging. Let's confirm. And last thing I want to show you here, that CI job will clean your Snowflake instance. So you will not see this temporary staging schema. So you don't need to do this manually, and you will keep your warehouse clean. It will disappear, just a moment. It takes a little bit time after merging. Is it merged? It's merged. Just a moment. But believe me, it will disappear. It's merged. Yes, it's merged. Yeah, we haven't got it here. Great. So, guys, let's recap the benefits. So, as you see, this CI job is really cool feature. If you don't use it, start to use it. It's really helped you to have your code reliable with automated checks, and you see how your changes behaves before you merge them into production. So less stress during the releases. You're reducing your risk of bad data reaching to production, and also, it's the very important thing, just save your money, save money to a company, and of course, you will have more time on other interesting, funny stuff. Thank you. And I'm handing it over to my colleague, Luboš. Welcome, Luboš.
Thank you. Let me share my screen. Right. Hello, everyone. My name is Luboš, and I'm a data engineer here at Rebel BI. And today I will be talking about the new dbt semantic layer and MCP server. Well, first of all, what is a semantic layer? It's a collection of all the metric definitions, all the relationships between data entities that determine how the data in your warehouse should be read by a BI tool or by an end user. It usually sits between the data warehouse itself and a classical BI tool or the end user. And how does the semantic layer look today? Well, imagine an organization where you mostly use Power BI for as a BI tool. Well, you define the whole semantic layer there. It sits in your data model underneath the dashboards. But maybe you have another team that for some reason prefers Tableau, and they do this all over again by themselves. They define all the metrics and so on, and they have no real connection to the first team. Then maybe a separate team pulls data from Google and prefers to do the visualizations easily in Looker. They have to do this all over again. And perhaps someone does some kind of advanced analytics in a Jupyter notebook. Well, same story. Semantic layer is also defined in various, and all your metrics are defined in various docs, maybe scattered around Confluence. And semantic layer is also that old Excel file which has not been updated for 3 years. Why does this happen? There's various BI calculations that are all over the place at different places that don't really talk to each other. There are also manual exceptions sprinkled somewhere throughout, possibly, and there's no real coordination among teams on the exact metric definitions. So what that leads to is some ambiguity in the numbers, because for one metric you can easily find 3 different definitions and 3 different values. It slows down decision making, because before you actually decide anything, you first have to spend a lot of time actually deciding what means what. And it can also lead to a loss of trust in the data by the users. And while this is a hot mess for any human user trying to consume the data, the real problem is, well, good luck to any AI agent that tries to read this. And believe me, you want them to read it, because in the next few years you want to be future-proof. So how would a semantic layer, like a dream semantic layer, look if I wanted to really make it future-proof? You want unified metric definitions that ideally live in one place, where you can do some sort of version control on top of them, and perhaps some CI/CD. You also want to reuse them across all your different downstream tools. Like I mentioned earlier, you possibly have several BI tools, maybe some notebooks, but the main thing going forward is that the layer is readable by AI tools. Well, why did this mess keep happening? Because there was no widely recognized and accepted standard for how a semantic layer should be structured, how it should look like. But recently, DBT has come up with metric flow, which is the new industry standard for such a semantic layer. It's designed to be readable by end users themselves, by conventional BI tools, but again, mainly for the AI tools and AI agents going forward. It is already accepted by most of the main players in the industry, by the major BI tools like Tableau and Power BI, and most of the major data platforms. It plays with Snowflake, plays with Databricks, with GCP, and others. What it does, it defines all the metrics, dimensions, relationships, time grain, like any proper semantic layer should do. It lives inside your DBT repo, where you can do classic adult version control. And as I mentioned, it can be connected to all the major BI tools and some notebooks. And again, main thing, it is ready for AI agents. On top of this, DBT also introduced their own MCP server. What it does? Well, what is an MCP server anyway? It is a protocol that provides additional context for any AI tool seeking to connect to your data and your DBT project. It structures the way your the LLM interacts with the data. Sometimes it's a bit of a simplification, but I sometimes compare it to an API for AI, in the way that it's again structures how some sort of downstream tool should interact with the underlying data. Where API has endpoints, MCP has something called tools, which again are defined, structured ways of how it should how the AI should interact with the data. So what does the MCP server do? Once you connect it to your AI tool of choice, it accesses the entire context of your DBT project. It can see all the models. It can see all the underlying data living in the warehouse underneath, and it does so through not only through, but mainly through the semantic layer we have talked about earlier. And because, as I mentioned, the tools are designed to deliver the structured results, to reduce any sort of AI freestyling, which it is prone to do. It allows users and AI agents to interact with the whole of their DBT project using natural language, and while the results are consistent. Well, let's now take a look at how it can look in practice. First of all, I will briefly show you how such a semantic layer can look when it is configured. I will then outline what you have to do to set up your own local MCP server, and then I've prepared a demonstration of how such a quick conversation between me, the AI tool, and my DBT project can look like. So let's start with my DBT project. As you can see, I have a really small demo project with a few main models in my MART layer. On top of them, and this is where it starts to get interesting, I define those semantic models. Those are standard YAMLs, as you are probably used to if you work with DBT, which define all the different entities in the model, all the facts and how they should be aggregated by default, all the dimensions and time dimensions, and so on. I've done the same for payments. And then on top of these models, you define the metrics themselves, where they reference the semantic models. They can reference each other. And now let's take a look at what you have to do for your own MCP server. I'll be very brief. It's not that complicated on paper, at least. It's you have to clone the DBT MCP repo, which is publicly available on their GitHub, and also you have to clone your own local DBT project. Then after an afternoon or two of debugging, you use some packages to run the MCP server itself, and finally connect it to an AI tool of your choice. I picked Cloud Desktop. So I've cheated a bit and prepared the conversation beforehand, because usually the prompts take about, I don't know, if you include the visualizations, they sometimes take upwards of 10 or 20 seconds. So let's not waste our time. So the first thing I probably want to do is actually look at what metrics can I even see. You can see here that the first thing Claude did was call the metrics tool, and then showed me what are actually the metrics I can use. I'm now interested in revenue per customer. So let me ask Claude what he can show me about it, and visualize that in time. Now I can see that, first of all, it's querying another tool, which fetches the dimensions I can use for this metric. Then it queries the metric itself. And finally, it creates a visualization of the metric, along with a few quick insights. But okay, I don't like line charts for some reason. Also, I have only 2 months of data, so it's not that pretty. Let me just ask for a bar chart with an overall average. Cool. Here it is. Okay, if I want to prepare for some sort of meeting, I guess I want to ask about some basic metrics, probably maybe revenue in time. So again, I get a quick summary, but this is way too superficial for me, so I want to break it down by a payment method. And because I like bar charts, as I've already shown, I want this as a stack bar chart. So here it is, and okay, it's this is getting a bit more in depth, and this is cool. I can now see that all my payment methods are on the rise. And I can see that they are spread fairly evenly, or the orders are spread evenly among them. And now what I want to see is order count. So I asked Claude to show it to me in a similar way. And because I've already asked for the previous metric to be broken down, Claude thought about, okay, he probably wants this in a bit more detail, and the dimension that makes sense for order count is probably status, which I agree with. So here we go. Okay, and besides just visualizing it, I can now see that Claude has already noticed some weird things happening, and that is, okay, I have some test data here, which I probably should get rid of in production. And I've already seen highlighted that I have a staggeringly high return rate, which I probably should do something about. And also there seems to be some problem with my fulfillment. And I don't even need to analyze the data because this is just served to me on a silver platter. So since I mentioned I want to do a meeting tomorrow, I want to prepare for this, and I want a quick summary for this. So I asked Claude to make a little dashboard out of all the metrics I've queried, and summarize some of the key findings. So I have I can have a quick look at the numbers. It's already highlighted the return rate, which is quite alarming actually. And I have a quick executive summary, which I can address. We can also look at all the charts we made earlier. And what's pretty cool is that I've already have some recommended actions to do what to do with all the problems we've really quickly found in the data. So, here we go. To summarize, what this means, what this means for my future DBTs is this combination of semantic layer and MCP. I have one version of truth, which is consistent across all my BI tools and more. I'm ready for AI because, honestly, this is pretty cool. Conversing with a chatbot and getting most of the insight I used to spend much more time earlier preparing. That's nice, but imagine what an AI agent can do on top of this instead of me. I have reasonable governance and version control finally, even on this level of the semantic layer, because now metrics are consistent and they live in one place, I can have faster onboarding and delivery, so I don't need to spend a lot of time gathering the information in various places. And I'm also less prone to vendor lock-in because it's much more easier to just swap a BI tool on top of an already finished semantic layer. And if you liked what you saw today, don't hesitate to get in touch with us, and we will be happy to talk to you more about this and maybe showcase it to you more in depth. Thank you.
Thank you, Luboš. And thank you again for joining us today. We are truly excited to be able to share this news with you. And if you have any questions, please post them in the chat and we will try to answer some of them. And also in the chat, you can find the link to its form. If you want to talk with expert in our company, you can fill the form and we schedule the meeting with you. No. Really? Okay, it looks like we don't have some question. In semantic layer available in DBT Core in Fusion, it's semantic layer, it's available on DBT Cloud. It's mean Fusion, but in the cloud you can able or run also on DBT Core versions. It's both of them, but you must use DBT Cloud. I'll mention if yes, it's available in DBT Core, which able to run in DBT Cloud platform. Luboš, you can answer it or?
Right. Level of security is handled by the token which you use the MCP server under, so you can define all the access on the token level, and so there's it's already handled on here.
How to handle in the orchestration felt. Okay, it looks Maciej, it's expert on the DBT, and try to answer in the chat is detailed. And how to handle orchestration failed test before loading in the next layer. If you're working with the DBT automatically know the reference, right? And the reference, it means if some models in the middle of flow, it's failed or test is failed, and you have to set up the test failure on the error, it will not continue to the next layer on the next steps. sorry, I mute. It is possible to write from 2 and more mappings to one table. What exactly you mean? It failed on testing stage model 2, but mardim was already loaded in stage model 2, but mardim. Okay, Matthew provided the answer, but I recap. If stage model 1 is built and test on stage model fail, the rest of the lineage, how I mentioned downstream, won't be built because the stage model test failed and DBT automatically know the dependencies between these models. Okay, thank you so much for your attention. And if you want, you can scan the QR code and fill the form. Thank you. Bye and see you next time.